Alright, so welcome back again. So the title of this presentation is HELIOS V2, but this time around we're going to be using the Canon Regressor. The other time we used the Canon classifier where we got an accuracy of 93.5. This time around we will be using the Canon Regressor. So this is all my code. I'm going to go straight into running the app. This is the Python code for the regressor agent, and this is the Python code for the user interface. So I'm going to go run this code over here through the terminal, and of course it's going to open up. Awesome. So we have HELIOS version 2 sleep quality prediction using Canon Regressor. Now if you may recall, when we used the classifier, the system automatically selected the best k nearest neighbor off of the k grid, which we have over here to the right side of the screen. So what I'm going to do is I'm going to eliminate all these other values and leave only 13, so we can see how this regressor system, how this Canon regressor model performs against the Canon classifier model, which we got a 93.5% accuracy. So now I'm going to click Train Canon Regressor. And as you can see, we have a 95.9% score from our R-square. So that's about a 0.5. Yeah, about, because the former one we got 93.5 and this is 95.9, basically 96. So that's about a 2% differential. Not entirely really significant, but that is the difference between both of it. Now, earlier on, the code was not fully semi-autonomous. The user had to impute these values all themselves. However, and you would make a prediction. However, if you're designing for like a smartwatch or whatever, you want the system to collect the data yourself. So for this regressor model, I have gone ahead to implemented a semi-autonomous function. So instead of the user having to manually enter all of this themselves, I have added a simulated function where the data will be generated based off of the user. So imagine you're wearing a smartwatch and the data is being collected based off the metrics from your body, the readings from your body. So I'm gonna toggle this field right here. This is the reveal speed. So this is the speed at which the data will be revealed to the user, and this is just a numeric jitter, just a little bit of animation. And when I click on simulate inputs plus predict, it does this really nice stuff where it predicts the wearable. You can see I tagged this incoming wearable data, and it predicts all of this, and I don't have to click on the predict button with the other one. With this one, it just instantly does the prediction, and I can see it right here. Very little user interference. I'm just gonna run that one more time so it can be seen. If I click on simulate inputs plus predict, you can see it does it really slow, much more slower this time around, and you can see the person ID. These are all randomly generated. So and you can see this is of course different. This is a different value, 7.7 all over 10. This is the predicted slip quality, and because of course, if you remember, we're using the k nearest neighbor as 13 here. If you go down all the way over here, you will see that these are the neighbors that is being used to predict. And of course, if you go back to manual, you can still manually enter all this data if you wanted to. And so as always, you can perform a batch prediction if you have a ton of users, or if you're comfortable with the model, you can choose to save the model and use it for a later date. That is my presentation. Thank you very much.